Hi everyone, it's Math with AUB with another elegant frame based on second year questions, courtesy especially of Aga Khan board. I've selected some questions for you to attempt Aga Khan board. At least I will give you a bit of advice. Your first step must be make or break. Your first step must be make or break. To attempt Aga Khan board question, there are two ways. One is the lengthy one. The other one if you utilize the property, if you utilize your acumen, then it is going to be solved in 2 to 3 steps. It's a wonderful. I like the pattern of our Khan board, especially the start, how to attempt these questions. Question number 1, we have given three functions. F of x is equal to negative times root x square minus 1, f of x is negative times x cube, f of x is x cube. We have to hunt which one is odd. Yeah, how many are odd? Which one is odd? Let's see and find out. Let's apply postmortem on question number 1. It's given to us minus x square minus 1. To check whether it is even or odd, replace x by minus x. Replace x by minus x. If there is no change, the function is even. If the symbol of the complete function on replacing x by minus x has been changed, function is odd. If it is somewhere between, midway between, some symbol change, some not, then it is neither even nor odd. Okay, let's check. Replace x by minus x. Minus x replaced by minus x. Power is even. Owing to the even power, base minus can be converted into positive, negative x square minus. It remains same. So f of minus x is equal to f of x. The given function is even. It is not our required result. We are interested in hunting odd function. The other one is f of x is equal to negative times x cube. Replace x by minus x cube. Power is odd. Owing to the virtue of the odd power, minus of the base remain intact. Negative times x cube. Why is minus? Plus it's x cube. Look at this. F of minus x is equal to negative f of x. On the start, on commencement, the function is negative. Now it is positive. Symbol has been completely changed. So the function is odd. This is an odd function. This function is an odd function. Wait, and check the other one as well, the third one. F of x is equal to x cube. Replace x by minus x. F of minus x is equal to negative x cube. Owing to negative power, minus base of minus remains intact. It is so. F of minus x is equal to negative f of x. The symbol has been completely changed. Means our option number 2 and 3 are odd. This is an odd function. This is also odd function. This one is even. Second and third are even. Second and third are odd functions. So option number D is our right option. In that case. Mostly people leave the question here as it is odd one. It might be more than one odd. Look at this. It is mentioned among the following functions, which one is odd function? There is a bracket as function or functions possible. That's why check overall all the functions. Okay. Next, the value of x. Means you should have good idea about. Sorry, I have erased net ECAT. And which of the following point does not belong to the domain of the function? You should have fair idea about the domain of the function. Let's see and find out. F of x is equal to x square minus 4. It is a real valued function. Somewhere it is mentioned real valued means we are not interested in complex values. Means in root we cannot afford negative values. So x square minus 4ac greater than or equal to 0. Greater than or equal to 0. We can afford 0 because if it is overall equal to 0, it is overall equal to 0. Root 0 is a real number, that's 0. Root 0 is a real number, that's 0. That's why I have written greater than or equal to 0. Greater than or equal to 0. Okay. If that is the case, f of x is 1 over x square minus 4, then I would have written x square minus 4 is greater than 0. Greater than 0. Why? Because if this is equal to 0, deviation with 0 is not allowed in mathematics. Deviation with 0 is not allowed in mathematics. Look at the tiny and slight, very fine difference between these questions. If function is in the numerator root, then greater than or equal to 0 also works. If it is in the denominator, overall function we cannot afford 0 because deviation with 0 is not allowed in mathematics. Fine difference between these two sorts of questions. Look at this. Examiner will challenge you to give sometime this, to give sometime this. You should have a fair idea. 0 to be included, 0 to be excluded. Okay, without wasting time, moving forward, x square is greater than or equal to 4. Or mod x is greater than or equal to plus minus 2. Mod x is greater than plus minus equal to, look at the way, means minus 2, minus 1, 0, 1, 2. These are the values we can afford towards this one, towards left, and this one towards right. We can afford. We cannot afford, we can afford minus 2 as well, positive 2 as well. We cannot afford these values. This is our blind spot. This is our Achilles heel. This is the interval where function gives us complex values. Put 1 minus 1 here, 1 minus 4, it is negative 3. If I put 0 here, 0 minus 4, it is negative 4. This is our blind spot. We cannot afford such type of value. That is the orthodox way to find the domain. To find the domain means our domain is negative infinity, negative to included, union from positive 2 to positive infinity. Infinity is not a number. That's why we have given open. Open means it is not a number. How we can include infinity? It is a behavior we have to show. Towards right we can travel, towards left we can travel. Okay. Narrow down the focus to this question. We can afford 2. If I put 2 here, 2 is in my vicinity, 2 is in the domain, minus 2 is also in the domain, minus 4 is also in the domain, minus 1 cannot be, minus 1 cannot. If we put minus 1 here, it will give us minus 3. Okay, moving towards next question. Next question is for the function f of x is x square and g of x is x plus 1 whole square. Then the composition of f and g when x is equal to minus 1. When x is equal to minus 1. Next question is based on composition of functions. Question number 3. Question number 3. Let me change my marker. It's not reaching. Okay. For the function f of x is equal to x square and g of x is x plus 1 whole square. Then we are asked to find fog when x is equal to minus 1. Fog when x is equal to minus 1. Fog when x is equal to minus 1. First find, prepare g of minus 1. Put instead of x minus 1 in g, minus 1 plus 1 square, 0 square 0. So f of g inverse of minus 1 is equal to 0. It's 0. It means in the function f of x, put x is equal to 0. 0 square. So 0 is the answer. This is known as composition of function. Let me give you idea how to find composition of function for f g of x. What is g of x? G of x is equal to x plus 1 whole square. It means in function f of x, it means g of x means x plus 1 whole square. We have inserted the value of g of x. Now it is f of x plus 1 whole square. Instead of x, we have x plus 1 whole square. So in that function, instead of x, utilize x plus 1 whole square. X plus 1 whole square and square. Instead of x, utilize x plus 1 whole square. G of x is equal to x plus 1 whole square. I have written x plus 1 whole square. That's our square. Means x plus 1 whole power 4. Whole power 4. Whole power 4. This is the value to be utilized instead of x. Instead of x. F of x is x. Instead of x, I have written x plus 1 whole square. Instead of x, I have written x plus 1 whole square. This square remains same. 2 to the 4. That's our answer. And we are familiar that fog does not equal to golf. Generally, fog does not equal to golf. Let me calculate this for you as well. G of f of x. What is value of f of x? That is x square. It means in the function g of x, replace x by x square. Replace x by x square. It is equal to, instead of x there must be x square plus 1 whole square. In g of x I have utilized x square instead of x. Instead of x I have written x square, the rest remains same. So one can easily infer that fog is equal to x plus 1 whole power 4 and golf is equal to x square plus 1 whole square. Means fog does not equal to golf. Fog does not equal to golf. They are not commutative. They are not commutative. They do not satisfy abelian property. Okay. Moving towards next question. A good question. Your first step must be make or break. Question number 4. Find differentiate with respect to x, ax e square. Look at this. Twist in the tail. E square is pure constant. E square is pure constant. It's constant. It's not a variable. It's a not variable. So there is no question to apply product rule on that. As E square is a pure constant. E square is a pure constant. E square is a pure constant. So there is no need to apply product rule. There is only a power x, a raised x, a raised x. I used to convey in case of in differentiation you have 3 to 4 types of data. Normally you have such cases x raised to 5. I used to call it base variable power constant. I used to call it normal case when base variable power constant. How to handle this? Drag the power down, subtract 1 from the power, write the derivative of base. Make the power coefficient, drag the power down, make the power coefficient, subtract 1 from the power, then derivative of base. It's our normal case. I used to call it base variable power constant. The second case to me is that a raised x, such type of data, a power x. Look at this. It is almost base constant, power variable, base constant, power variable, base constant, power variable. So there is no question of making the power coefficient, drag power down, subtract. It is not the strategy in that case. That is the strategy. Write same derivative of power with respect, then base with ln with base, Look at this. When base is constant, power is variable. Base is constant, power is variable. Visible difference between these two. X5, look at this 5x. These two are not the same cases. Base constant, power, write same differentiation of power, then write base with ln, write same a raised x, power of x, power is x, differentiation of x is 1, then ln and then ln and then ln. So in that case our answer is going to be, as e square is a constant, this one apply same strategy, write same derivative of power, derivative of differentiation of x is 1, then write base with ln a. So it's our answer, e square a times x ln a. I used to call this base constant, power variable. The third case is when both variable, like x power sine x, base variable, power variable, base variable, power variable. These are 3 to 4 categories of data. I have explained to you two. When base variable power constant, normal case, that's not normal. Base constant, power variable. How to handle its differentiation? Write same differentiation of power, then write ln with base. L with base. Okay. Moving towards final question is also based on differentiation. Also based on differentiation. It is differentiation of, find derivative of ln a square x. Look at this. If you utilize the tiny property of differentiation, it is going to work wonders for you. It can be written as ln a square minus ln times ln x minus ln x. Property of log ln a over b can be written as ln a ln LNB, we are familiar. We are familiar. 2 to 3 very famous properties of log. This is the one. Now ln a square is a pure constant. Ln a square is a pure constant. Pure constant. Derivative of constant is 0. And derivative of ln x is 1 over x. Derivative of ln x is 1 over x. Whatever is with ln, write in 1 over. Whatever is in denominator, write its derivative. Means minus 1 upon x is the case. Minus 1 upon x is the answer in that case. So in that case, our answer is minus 1 over x. Minus 1 over x. I have explained to you 2 to 3 types of data while differentiation. Let me explain to you third when base variable, power variable as well. Suppose we have given y is equal to x raised x. How to handle this? Giving ln both sides. Giving ln both sides, ln x raised x. Now, according to property of log, power become coefficient. Power can become coefficient. It is the property of log x ln x. This is the property ln a raised b can be written as b times ln a. Okay. Now differentiation of ln is 1 over y into differentiation of y dy over dx. Whatever is with ln, write in 1 over. Whatever is with ln, write in 1 over. Whatever is in the denominator, write its differentiation dy over dx. Here, two functions, they are in multiplication, product rule. X same, differentiation of ln x is 1 over x. X same, differentiation of ln x 1 over x. Plus ln x same, differentiation of x is 1. X cancelled over, shift y on the right hand side. We are interested in dy upon dx. Dy upon dx is going to be 1 plus ln x. That's our y. What is the value of y? It is given to us. Utilize here 1 plus ln x times x raised x. That is your third case. Our first case, base constant power, base variable power constant. Base variable power constant. Types of data. Second, base constant power variable, and the third one is both variable, x raised x, base variable as well as power variable. I have shown you a little movie. Normal case to be handled effectively. Everybody knows that it causes trouble and it is a really problem for you. If you have a good idea about their differentiation, then you are in a position to integrate them in an efficient manner because you are familiar from the data. What sort of data it is? Base variable power constant, base constant power variable, and both are variable. It's my tiny effort to you guys explain to you these questions, especially taken from ECAT and Aga Khan board. It's all by itself. Next.